Okay, we're going to do this problem, which is coming up in chapter 4. It's problem 469b, and we can see it's a subtraction of rational expressions problem. And so the first thing that we need when we're adding or subtracting is we need to think about a common denominator. And in order to do that, we need to get the denominator into factored form. So we already have factors here, 2x plus 3. We need to get this expression into factored form. So I'm going to do the box and diamond here quickly to figure this out. So 2x squared, actually I'm going to make this bigger so that I have enough space. X squared minus 6. Those get multiplied together to make negative 12x squared, and then this middle term here goes on the bottom. Then we're thinking about what do we multiply to get negative 12, and what do we add to get negative x. Since it's negative, it's going to be plus and minus. I'm seeing these terms that will work, and so I'm going to put them into my area model. And then I know I need to take 2x times x to get 2x squared. And it makes sense to line up the x with the 3x and the 2x with the 4, because 2 goes into 4. In fact, 2 goes into 4 2 times. So 2x times negative 2 would give us negative 4x. And then x times 3 will give us that. So our factored form of this is 2x plus 3 times x minus 2. And then we're thinking about how do we find our common denominator? Well, we have 2x plus 3 in this denominator, so that's going to be part of our common denominator. And we have x minus 2. And then we need to make sure that everything in the second fraction is represented as well. We already have 2x plus 3, so we don't need to list it again. So this would be our common denominator here. So we don't need to change anything in the first fraction. We don't need to multiply it by anything because it already has the common denominator. But we do need to multiply the second fraction by x minus 2 because that's missing. So we need to multiply by x minus 2 here and x minus 2 here. So that means we'd have x plus 2 times x minus 2 all over our common denominator of 2x plus 3x minus 2. And I write this for two reasons. One, I'm lazy, I don't want to write out the common denominator. But the second reason that's kind of more important is to realize that we don't want to deal with any giant ones until we get to the very end of this problem. And then I'll bring back the actual common denominator to remind myself to look for giant ones. So in the meantime, we are just going to deal with the top of this fraction. And right now it's in a pretty ugly form. We have the first part in standard form and the second part is in factored form. And in order to actually do the subtraction here, they need to be in the same form. And definitely standard form is going to definitely be easier. So I'm going to multiply out the x plus 2 and the x minus 2 to see what we get. So when you multiply that out, and maybe you knew this because of the difference of squares idea, but those two things multiply out to be x squared minus 4. So the new top of our fraction would be 4x squared minus 11x plus 6 minus x squared minus 4 all over our common denominator. And then, if this was a plus sign, we wouldn't have to worry about it, but since it's subtracting, we need to distribute that negative sign to both, so it becomes minus x squared plus 4, And then we're just going to combine the like terms. So I have 4x squared minus x squared, which gives me 3x squared. I have negative 11x and no other x terms, so minus 11x. And then I have plus 6 and plus 4, which gives me plus 10. We'll keep it all the same color, all over our common denominator. I can't add this together anymore, and so now that I've added as much as I can, combined all the like terms, now I can go back to look to see if there's something I can do to factor it. So is 3x squared minus 11x plus 10 factorable? Well, we're going to add a new page and see 3x squared. And I already forgot what it was. Minus 11x plus 10. (3x squared) and 10 multiplied together gives us 30x squared and negative 11x. Oh, it is factorable. Which means I'm going to write my 3x here and my x here, because 3x times negative 2 gives me negative 6, and x times negative 5 gives me negative 5x. So my factors are 3x minus 5 times x minus 2. 3x minus 5 times x minus 2. Going back to my original common denominator, which was 2x plus 3 times x minus 2, we see that we can make a giant 1 here, which means our final answer would be 3x minus 5 over 2x plus 3. So that's it for simplifying the rational expression. I cannot simplify this anymore because these are not being multiplied. We have a minus sign and a plus sign between them. So the top is one whole factor and the bottom is one whole factor, and they're not the same factors, so we can't make a giant 1. But we're not totally done with this problem, because in any rational expression problem, we have to recognize that there are excluded values. And so to find our excluded values, we go back up here and look at our common denominator. So we had 2x plus 3 and x minus 2. 2x plus 3 and x minus 2. And in order to find the excluded values, we know that these cannot be equal to 0. So we're going to solve for x to find out what would make it equal to 0. This one's easy enough. Add 2 to both sides. We know x cannot equal 2. That's one of the answers. This one takes a little more work, so I'm going to write it over here. The first step is to subtract 3, so then I get 2x equals negative 3, and then divide by 2. X can also not equal negative 3 over 2, because if x equals either of these things, we'd end up dividing by 0, and that would not be good. So these are our excluded values.